Consider the following matrix: 2, 3, x and y. If the eigenvalues of A are 4 and 8, then what is x and y? The question. So by using the property, suppose if you take lambda 1, lambda the eigenvalues of a matrix 2 cross 2 matrix, then the sum of eigenvalues is equal to trace of A. Product of eigenvalue is modulus, that means the determinant of A. If you substitute lambda 1 is equal to 4, lambda 2 equal to 8, then you may get trace of A equal to 2 plus y. So 12 equal to 2 plus y, you may get y equal to 10. Similarly, if you take a determinant, the determinant of this matrix is 2y minus 3x equal to lambda 1, lambda 2. That means 32. So if you equate and substitute y values in this expression, you may get x is equal to minus 4. The number of different n cross n symmetric matrices with each elements being either 0 or 1 is. So here, every symmetric matrix, suppose if you take a n cross n symmetric matrix, if you want to form n cross n symmetric matrix, the first row you need to use n terms. In second row, it's enough to apply n minus 1 term only, because the second, that means first row second element and the second row first element, it should be same. So for that, no need to use first element in a second row. So then because we have applied this term, then only you can say this is a symmetric matrix. So for that, except this term, you need to use n minus 1 terms. Similarly, up to n rows, you can define number of terms you need to fill the symmetric matrix. So from that, you can write the number of terms need to form a symmetric matrix of order n is the addition of all the terms. So if you add all the terms, this addition is nothing but sum of n natural number. The formula to add the sum of n natural number is n into n plus 1 divided by 2. Right? So but here, now we are going to apply only two terms, 0 and 1. So suppose 0 and 1 comes means the number of difference n cross n symmetric matrix is modulus b whole power n into n plus 1 divided by 2. So modulus b is nothing but the cardinality of b. So 2 power n into n plus 1 divided by 2. The answer is 2 power n square plus n divided by 2. This is the answer. The eigenvalues of a 3 cross 3 matrix are, so first I'm going to find the characteristic equation. Lambda power 3 minus s1 lambda square plus s2 lambda minus s3 equal to 0. So s1 is nothing but trace of A, that means sum of main diagonal elements. So you can get 3. S2 is sum of minor of main diagonal elements. So you have to find minor of this term. Next one is, and you have to find minor of second row, second term, and the minor of this term. You make it equal to 0. And S3 is a determinant of A. The determinant of this matrix is 0. You can apply S1, S2, S3 in this formula. If you apply, you may get a lambda power 3 minus 3 lambda square equal to 0. If you take lambda square as a constant, common term in this 2 expression, from that you may get lambda square into lambda minus 3 equal to 0. If you equate, you may get lambda equal to 0, 0, 3. So consider the matrix. If a power n is equal to I, then you have to find n. So here n should be a non-zero term. N should be non-zero. n integer. That means positive integer. So here, this matrix is a orthogonal matrix. It is orthogonal matrix. So by using this property, if you take the power of this matrix, automatically it's enough to multiply the angle of the corresponding trigonometric function. It's enough to multiply. From that you may get the power of this matrix. This is the speciality of orthogonal matrix. So here I am going to apply this formula here and equating uh, identity, right? So from that, if you want to make this term, it's going to be 0, means you have to equate this term equal to 1 and sine n pi by 6 equal to 0. So from that you may get the answer. So from that you can apply, you can take the cos into left hand side. From that you may get cos inverse of 1. So cos inverse of 1 is nothing but you may get different values. 0, if you apply 0 you may get cos theta equal to, for different theta of cos you may get a 1, 0, 2 pi, 4 pi, 6 pi, minus 2 pi, minus 6 pi, minus 4 pi, like that. But here I am going to find n should be a positive integer, smallest positive integer. So for that I am going to apply 2 pi. If you apply 2 pi, you make it n is equal to 12. Similarly, here also you can apply, so for first term, so here, if you want to equate this term equal to sine pi, you won't get, you won't, that term, it's not satisfied the corresponding term, because if you apply n is equal to sine pi, you may get n is equal to 6. But here you may get n is equal to 12, but here you may get n is equal to 6, but it is not satisfied. But in this function, you can find n is equal to 12 also. If you substitute instead of sine pi, sine 2 pi, you may get the corresponding value. But as n is equal to 6 is the minimum value, but not satisfied in this expression. So for that, I am going to take n is equal to 12 as the smallest value of n that does satisfy this condition a power n equal to I. If ab equal to a and ba equal to b, then you want to check whether a is idempotent or b is idempotent. The definition for idempotent is a is idempotent if a square equal to a. So now first I have multiplied these two equations from the left hand side and right hand side. So from that you may get this expression a square a into b square a equal to a b. So you can cancel the first term a and a. So from that you may get b square a equal to b. Our aim is you want to get b square equal to b. So for that, instead of b, suppose if you cancel the term, you won't get anything. For that, I am going to replace b by ba. So here b comes in the left hand side, right hand side. Here also b comes in the right hand side. You can use right cancellation law in the matrix. You can cancel these terms. From that you may get b square equal to b. So from that you can say p is idempotent. Similarly, if you multiply ba second equation to first equation, so from that you can find a square equal to a. So a is idempotent. So if ab equal to a and ba equal to b, means a and b are both idempotent. But if in this case definitely a and b not equal, that means non singular is most important, then only you can prove this result. Modulus a, and that means the determinant of a and the determinant of b is not equal to 0. That means a and b should be a non-singular matrix. Then only you can prove this result. Let AB 3 cross 3 matrix, a square matrix with eigenvalues 1 comma minus 1 comma 3. Then among these four matrices, which one is non-singular? This is the question. So a matrix is non-singular. When do you say that a matrix A is non-singular? If the determinant of A is not equal to 0. That is, the eigenvalues of A are non-zero, or you can say 0 is not a eigenvalue of A. This is the meaning. So from that, so now by using the properties of eigenvalues, you can find out the eigenvalues of every terms. It is possible to find all the eigenvalues of each new matrix. So I have calculated here. So now among these eigenvalues, first, second, and fourth. So this is not a singular, non-singular. So this is singular. This is singular. This is also singular matrix. This one is non-singular matrix because all the eigenvalues of this expression is non-zero, right? Let the matrix A, this is upper triangular matrix. You want to find adjoint of A. So we know the formula. Adjoint of determinant of adjoint of A is determinant of A power n minus 1 whole power 2. So if we are taking two adjoint, you have to put a 2. Suppose only one adjoint mean it's enough to increase the power n minus 1 only, right? So here n is nothing but order of this matrix. Now you can find out determinant of A. So the matrix is upper triangular matrix. So the determinant of a matrix A is only the multiply the corresponding main diagonal elements. The multiplication of this value is determinant of A, right? So A equal to minus 2. The order is 3. So now try to substitute n and modulus determinant of A in this formula. So after the simplification, you may get the determinant of adjoint of A is 16. Let the matrix A is given. Find the determinant of A inverse. So this is upper triangular matrix. If you want to find determinant of A is nothing but simply you can multiply their corresponding main diagonal element. If you multiply, you may get minus 5. So now the question is you want to find determinant of A inverse, which is nothing but determinant of A whole power minus 1, which is equal to 1 by determinant of A. That means you may get 1 by minus 5. The answer is minus 1 by 5.